So to begin with, what is guidable inclusions and why do we need mobile testing? Well, we've come of an age where we had mobile phones which came in with which were large in size, which had small screens, which had large buttons, and through a generation of phones with antennas, we came to phones without antennas, and the size of the phone kept on decreasing. But then somebody felt the need that if you have a phone and if you could make it handy to be used for various other purposes, just being used as a phone, then it would be very useful. And that is where you saw the integration of things like an FM radio on your phone. So when you were traveling, you could listen to music. You had a music player. You had a video player. You started having memory cards to it, and so on and so forth. But then people said that with all these capabilities, we might want to make the phone. May I request everybody to mute? Right, sorry about that interruption. So, there was a need where people thought that people could include or make phones in such a way that people could use internet on their phones, which would enable them to access their emails on the go, which would enable to them to access any data on the go, whether they want to you know watch a video on YouTube or stream in some sporting activity, some games. So keeping all that in mind, the thought of a smartphone came into play, and with this smartphone coming into the industry, there was an array of applications that were launched, each application making your life easy. So whether you want to book a flight ticket, or if you want to simply chat with your friends sitting miles away from you, there is an application for almost everything. Almost all banks have their mobile applications these days. Almost every retail company, be it Flipkart or Amazon, they have their application so that you can sit in the comfort of your home and do shopping. So that is what the has been the evolution in the mobile phones industry, from phones which were a basic need where people could use it on the go, to a device which will enable you not to just talk to yourself but actually to see yourselves. And these days, with the advent of mobile technology, with the advent of mobile technology such as 3G, 4G, people do a lot of video calling where you could see yourself while you're talking. So the big question here was, why do you buy, need these mobile apps? That has already been taken care of. Having said that, each mobile app, if you do not test it, then it is of no use. So obviously, each of these apps, before they come into your phone, would need to be tested thoroughly. Now, before we proceed into the depth of mobile testing, let's look at the key differences between regular web-based applications and mobile applications. So mobile users are on the move while they are using the app. It makes it very important for the app to be tested on various networks. Say, for example, somebody is traveling from Mumbai to Pune. Now, when the person is traveling from Mumbai to Pune, or let's say if the carrier is Vodafone on your phone, then the phone automatically switches from the Mumbai circle to the Maharashtra circle of Vodafone, which means that your phone goes into roaming. So it is very important to see that when this transition actually happens, does your app respond accordingly or not? For example, on the go, if you are watching, uh, say, a YouTube video, then you would see that there is a glitch when the network switches, but then ideally you would want your video to be reconnected. If it is not, then there is a problem with the app. On the other hand, now you've seen that there are various networks which are available to you, whether it is 2G, 3G, or 4G. So it is important that when you have your applications built and deployed on these phones, they work on all these speeds. Now, they must respond to a 2G network almost in the same way as it would respond to a 4G network. However, you would see that there are drastic differences. Again, talking about YouTube, you would see that the videos load a lot faster in the 4G connections than on 2G connections. Quite obviously, because the 4G connections are meant to be faster and have a technology which support faster data transmission. Also, in case of mobile applications, there are different situations in which you will be wanting to use these applications. When you are, say, cycling or just walking around, or maybe, for example, watching a movie. So, if you're in a theater, you would want your mobile apps to respond to you in a different way than the situations where you are using them outside. Say, for example, if you have an app which allows you to have a dark theme where you could see read the message when you are sitting in a dark amphitheater watching a movie. So, for example, if you take the Twitter app, which of late has no launched a night mode, which would give you a good display in dark conditions. So, these are certain aspects which are associated with mobile applications. Now, the second thing is there are different user expectations. In case of mobile applications, because mobile applications are accessible to many people, there are a lot of expectations, each of them being unique. Now, from the same mobile app, I would want to do something else, and some other user would want to do something else. In such cases, it is difficult to cater to each and every user's needs. For example, if there is a retail shopping app, so the choice of items that I would like to see on that app may be different for me than for my friend. That is exactly what the mobile app manufacturer would need to think of while making that app. He would need to be able to create uh, a system where he is able to cater to each and every
Hey,
user.
Brijesh, are you sharing something on the screen? We can't see anything.
You can't? Okay,
Okay, now we
just
can. Again, it's gone.
do you see it now?
Yes, better. Thank you.
All right.
Yeah, no, it's not better.
Can everybody mute themselves? Thank you. All right. So coming to mobile apps now, a pattern that has been seen in case of mobile app usage is that 80% of the users they delete their mobile apps after using it for the first time. There are top four reasons. First of all, it is because of a bad design, or secondly, if it has got poor usability built into it, and if the app takes a lot longer to load, or if it crashes more frequently. Now, all these reasons obviously will annoy any user, and they would not want to uh, keep the app on their phone. They would rather proceed with, you know, an app which is much more stable. So, whenever an app comes in, there are glitches in that app, and over a period of time, those apps are actually made more robust. Just to give you an example, when ICICI Bank launched their iMobile app and they wanted specific selected customers to be using it, the app was so unstable that it would crash almost every alternate time. So you had to be very cautious about using that app. It was so annoying that a lot of users, they deleted their apps right after the first use. Then it took about 3 to 4 weeks for ICICI Bank to figure out the problem, and then they had to make sure that they provide more stability to the app. They change the design of their app so that it is much more user friendly, and that is where the app was launched again. Now, when people have poor mobile phone experiences, they are 48%. It is seen that 48% of them are less likely to use the mobile app again. In other cases, it is also seen that people switch to a competitor's mobile app. Again, you know, there are mobile apps for you know booking airlines and booking hotels. So two of the competitive apps are Make My Trip and Go Ibibo. People have seen that there are large differences between a Make My Trip app and a Go Ibibo app. So people who are not satisfied with Make My Trip switch over to Go Ibibo or the other way around. Now, this is a common pattern across almost all categories where there are competitive mobile apps present. The biggest factor here is that if somebody is not satisfied with the mobile app, the word of mouth causes a lot of damage. That is, people just start talking about that app, people start talking about their poor experience, and as a result, there is poor performance of that company. It reflects bad on that company as the sales go down. And a lot of users give very poor rating to the app. I mean, so the ratings obviously prompt other users to buy. And if you see a consistent low rating on a particular app, you would not want to buy it again. There is negative perception of the company. People, stop visiting the site, and you know, there is an overall bad reputation. Third, and the most important thing is the mobile device fragmentation. Now, in 2015, August 2015, OpenSignal came up with a report which showed the fragmentation of the mobile devices. Now, these mobile devices, if you've noticed, they are of various shapes and sizes. They vary from, you have the very minimal 3-inch screen to 7-inch screens or 10 inches. I mean, if you talk of iPads and other devices. Okay, so there is a lot of uh, variety that is available in these mobile devices in themselves. So when you build a mobile app, you must make sure that you cater to all the types of devices that are there in the market. Now, if you talk about the Apple devices have their set, screen sizes, and they don't play around much. But in case of the Android world, there is a lot of scope, because anybody or everybody is free to use whatever screen size they might want to provide to their users. And so that is why the amount of variety that you get in the Android world is way higher than that of the iOS world. Now, as of this is of course 2015 end statistic. There were 24,093 distinct Android devices in the year 2015, and out of which there were, which in comparison to 2014 was way higher, with 6,000 more types of Android devices that were there in the market. There were almost 682,000 devices that were surveyed in the Open Signal report, and it was found that Samsung's share of those devices was 37.8%. Now, interestingly, Samsung does hold the the market's largest segment in terms of devices. If you see that the a comparison of in their sales units in thousands for Q2 for Q1, the first quarter of 2016 versus the first quarter of 2015, you will see that the sales of Samsung has decreased a bit from 24.1% to 23.2%. The same thing has happened for Apple. Apple has lost quite a bit of market share in the first quarters, but you would see that other players such as Huawei or Oppo or Xiaomi have shown an increase. So this is again due to the variety that the Android world provides in comparison with the Apple world. Also, if you look at the operating systems, then Android still dominates in the past. This is a statistic from the last 2 years, and you would see that Android dominates, which is almost a little more than 50% of the market, and the rest of the 50% is distributed between iOS, which is the major player, and then you have Java, ME. Symbian phones are still existing, although Nokia is almost sliding out of the market. They pledge to come back, but probably with a different operating system on their phone. You still have Windows phones, you have Blackberries, and you have Kindles, and a few others just here and there. So, there is a lot of variation of screen sizes among and operating systems in these Android devices as well, ranging from 1.0 and now to 6.0. Of course, this is last year's statistic where you had Lollipop just coming out. So again, if you look at the fragmentation, uh, this is again an older statistic which has Lollipop in mind, but now we are seeing not only Lollipop but also Marshmallow phones dominating the Android world. And in the iOS arena, you have iPhone 6 and 6s, which are on operating system iOS 9, and I think the latest one is iOS 9.3.4, which a lot of phones must have received the update. Again, there is a huge screen size fragmentation as well, which is a huge challenge. So you see screen sizes of a variety of screen sizes, especially in the Android world. Now, all the phones they come up, they have a lot of sensors built into them, and you have been seeing that there are a lot of new sensors which are added onto the phones so that you could support gaming apps. And now with Pokemon Go almost dominating the games market of late, you will see that that particular app uses almost every sensor on your phone. Now, talking about the mobile apps, there are three types of mobile apps basically: native apps, hybrid apps, and web apps. And then there are three various types of app business models, which are freemium, paid, and transaction based. So these are all the differences and challenges that you have. Also, you know the app update cycles are very fast. In some cases multiple patches and releases are done. In some cases, such as Facebook, there are sometimes one or more. In fact, there are three updates that Facebook does every day. So and of course, to support the newer APIs, hardware and devices, there are a lot of changes that need to be made to these apps from time to time. With so many challenges that we have seen in case of mobile apps, there are obviously there is a need to devise a mobile testing strategy. It has to be different. It has to make sure that the mobile apps are tested systematically. They are. It needs to be made sure that the devices that these mobile apps are going to be tested are selected accordingly. And in order to make sure that we provide maximum test coverage, we need to make sure that we choose the right emulators, simulators, or real devices, depending upon what the app intends to do. Another phenomenon that has been prevalent in the market for the past few years has been the phenomena of crowd testing. This is where real users actually test the app, and they provide feedback on the apps, on their behavior. And then there are various testing types which obviously should be considered while devising your test strategy. So there is a checklist based strategy where you have a description of a particular test, and you have an expected result, and you run that particular test and you mark it checked. Once it is done, then you know and there are basically there are about 21 tests in all, which the checklist based strategy covers. So we are going to be looking a little less into this particular detail while we explore the other strategies as well. Then there is another important strategy, which is the mnemonic based testing. And there are multiple mnemonics which are available in the market today, which are very famous. One of them is the San Francisco Depot. Then you have the FCC cuts widths. You also have the long fun cup, and finally you have the guidable inclusions. Now, all of these testing strategies, they were developed with the intent of making sure that people use these as a reference from time to time, and this was used to so that people could use heuristics, and they do not have to do any additional research while doing their testing. They have this as a reference, and they could use it further for their testing. So let's just look at one of those, which is a lot famous, called as long fun cup. Now long fun cup is an acronym which has essentially 10 components. Now L stands for location, then you have orientation, then you have network, you have gestures, you have function, you have user scenarios, notifications, communication, updates, and platform. So this covers 10 aspects of mobile phones. This is quite comprehensive. This gives you good coverage. However, there are certain more elements which can be covered, and then those were picked up as a part of guidable inclusions. Now, this guidable inclusions is a part of the mobile testing strategy, which is a part of the CPM MAT course of Agile Testing Alliance. Guidable inclusions essentially covers 18 parameters, which is gestures, user scenarios and usability, integration, devices and platforms, accessibility, browsers, location, efficiency, interactions, notifications, compliance, localization, updates, synchronization, interrupts, orientation, network, and most importantly, security. So these are the various 18 parameters that are a part of guidable inclusions. And through this 18-part webinar, we are going to cover each one of them. Today, we are going to be talking about gestures in detail. So essentially, when you talk of gestures, now with the advent of smartphones, the most important thing was for the phone to be able to interact with you. That is, you had a screen to on which you could actually touch and do things. For example, if you want to type an email, you would have a keyboard application which would allow you to type the email. Then you would, if you want to see a movie, then you would have the movie player. You could resize or the movie screen according to your needs. You could change the orientation of whether you want to watch the movie in landscape mode or in portrait mode. Most people use their mobile phones as cameras. The camera feature has been built into the mobile phones. There are camera applications which allows you to take you know pictures, and so your interaction with the mobile phone increases. So there are phones which respond to your blinking, your winking. Then there are multiple patterns which you could draw on your phone. Say, for example, there are certain phones which have the capability of having apps which are purely gesture driven. For example, if you just draw a left arrow, then it starts playing the previous song. If you draw a right arrow, then it goes on to the next song. And then you have the horizontal swipe, the vertical swipe, the shape, the multi-touch, the single, double, triple tap. Then you have the touch and hold feature, the pinch and zoom, the smile, and then there are multiple other gestures which are a part of your games and variables. For example, if you have a smartwatch, then it and you put that smartwatch on and you go for a jog. It will tell you how much distance you have covered, and what has been your heart rate, and how many calories you have burnt, and so on and so forth. So this is what the gestures are all about. Now, gestures, basically people use these gestures to interact with these apps and their devices, and using these gestures, people have a personal connection with their phone. Now, the way I would use my phone, somebody else might not want to use the phone in that way. For example, on my phone, there is a feature which allows the screen to wake up on double tap. Now, a lot of people would want to use the lock screen key to activate it. Some people might also want to use the fingerprint sensor to open the lock on their phone, and they would not want to go to the hassle of waking up their screen, then typing in the password, and then going in. So there are different gestures that people have, different ways of interacting with your phone. It is purely on your comfort or on the user's comfort as to what features you want, what you don't want, and how you interact with your phone. Then why do you need these gestures? Each application has its own use, each application has its own way of interacting, each application has its own benefit. So each application is governed by its own set of gestures. Say, for example, I want to watch a movie on my phone. Now, there may be situations where I don't want to make sure that I'm traveling in public, and I just want to make sure that only I watch it. So I would not want it on a landscape mode, and I would just keep my phone on a portrait mode. But as soon as I find some space, I will just turn my phone, and the application understands that the orientation of the phone has changed. So the application by itself turns the movie into a landscape mode, and you are able to watch it better. So you see that the way in which you interact with the phone, it actually depends on what the application does. Now, what are the various gestures? Let's look at some of the iOS gestures uh, to begin with. Some of the gestures are tap, which is to press and select or control a particular item; to drag, that is to scroll or pan a particular item; then to flick, which is to scroll or pan again. Then you have the swipe, you have the double tap, you have the pinch, which is to zoom in or zoom out, you have the touch and hold, and you have the shake. Now, for all these gestures that I just mentioned, One very important thing is that at the background of these gestures, when you are actually setting yourself out to test these gestures, you must keep in mind that there are multiple sensors which are involved in making sure that the phone is interacting with you in the way you want to. And a lot of times we tend to focus on the gestures and completely forget about these sensors. If you have these sensors in mind, you will be able to test the gestures better. So it is important that you know all the sensors that are there on the device that you are currently using. Most phones these days come with the 10 basic sensors that are available. I have tried to list some of them. Uh, I mean, it will be your effort to go ahead and explore the various sensors on your phone and to discover uh, what each sensor does. Now, some of the most common sensors that you can see on your phone, if you could just take it out and hold it, and you will be able to locate these sensors. One of them is the ambient light sensor. That is based on the surroundings lighting condition. The phone's display automatically changes. The brightness changes, the contrast changes, and the ambient light sensor is the one which interacts with your surroundings and gives you that feature. So that is also a gesture in itself that the phone does in interacting with you. Then there is the proximity sensor. Now, if you notice that when a call comes, you take it closer to your ears, the light on the display screen automatically goes off. It is the proximity sensor which tells the phone that it is now very close to your body and the light needs to go off. Similarly, you have an acceleration sensor. Now, these acceleration sensor, interestingly, uh, locates your phone's axis, the XYZ axis, and it tells you into what direction, what speed are you accelerating. Now, if you notice the XYZ axis, you will automatically notice that the vertical axis shows an acceleration of 9.8 meters per second square wide by default, which is the acceleration due to gravity. Now, the moment you turn your phone upside down, you will see that the axis of the phone changes. And what was x-axis might turn to be y-axis after that, and so on and so forth. And that is exactly where the phone establishes the orientation of your device. Then you have the gyroscopic sensor. Now this is a little different from the acceleration sensor. The only difference being that this calculates the rotational acceleration that you have. This is very useful when you are taking, say, for example, these days you have phones which have the capability of taking panoramic pictures or videos, where you need to rotate your phone probably 360 degrees. So, on all six axes that are available. And this is the sensor which actually helps you explore the gestures that you are doing with your phone based on the rotation of the phone, and make sure that your app performs correctly. Then you have the magnetic sensor, which is very useful if you're using apps such as the compass, which gives you the directions well. It tells you obviously the magnetic poles of your phone in accordance to the directions that you have. So if you have the compass app, it will show you north because the magnet points to the north by default. Then another sensor that is built in on your phone. I mean, there are three different sensors, of course. One is the pressure, temperature, and the humidity sensors. Now, these sensors obviously are helpful in making sure that your phone is operating in the right environment. That is the right amount of atmospheric pressure, the temperature of the device and outside the device, and then the humidity in and around your phone. Now, this obviously enables your applications, especially the ones which are related to your health. They give you a good reading and they provide you all the necessary information. Then you also have the location sensor, which is essentially tied with your GPS, which tells you where your phone exactly is at a particular time. And then of late, you also have phones which have the touchless sensor. That is, you have features in certain apps. For example, the Photos apps to slide from one photo to another without actually touching the phone. by just sliding over the phone. So the touchless sensor is the one which captures this gesture of your slide above your phone, and it shows what it is. So when you are testing your application for various gestures, it is very important that you keep in mind that these are the sensors which are interacting with your application. So you might want to find out which are the various sensors which interact with your particular app, and then test it accordingly. Now, going a little backwards, I know that we are in the age and day of iOS 9, 9.3.4. We will take a look at some of the iOS 7 and iOS 8 gestures also prior to looking at some of the iOS 9 gestures. Now, the one of the gestures that iOS introduced or Apple introduced in iOS 7 was the swipe from the edges. The swipe from the left edge towards the right in mails, notes, or settings will go back one screen. So it goes back to the previous screen, and then you are able to make your particular choice. The swipe down from or the swipe up from bottom would brings the newly introduced control center, which was introduced in iOS 7 and which is still a part of iOS 9. Similarly, swipe down was another feature which gave the spotlight search interface. Then you have the swipe from the edge in Safari to go back one page. Now, if generally you would look for a back button, now in if you are using the default Safari browser on your phone, then this particular feature would do the function of the back button. Again, swipe right would go forward one page, and then there are a few other applications. For example, tab towards the left in the new Safari tab to close the tab, and so on and so forth. Then multitasking, for multitasking, you had the swipe up and the swipe down features or the gesture. Horizontal swiping will allow you to switch between adjacent notification centers. Then you know a horizontal swipe from left to right would bring up the on your emails would bring up the trash and the more options, which will let you take your decision and do the next thing with your email, whether you want to reply, forward, or flag an email. Now, swipe right from anywhere on the lock screen and you will unlock the device. Of course, if it does not have a password, if it has, then you might want to enter it. Or you could use the fingerprint sensor, which is there. Now, iOS 8, when it came, it came with a few interactive notifications gesture. The interactive notifications would allow you to interact with notifications on a swipe. So, if you have multiple notifications, then you could see each notification, and then you know whether you want to swipe it out or you want to take particular action on that notification. This feature was introduced in iOS 8. Then in the email app, you could mark it as read or unread uh, based on the left swipe that was there. Then if you swipe from to the left, or if you do a very short swipe on a particular message, then it gives you the option to trash an email, to flag it, or you could choose more options from it. This particular thing was you know an advance or an enhancement from iOS 7. iOS 7 only gave you the more and the trash, whereas this also gave you the option of flagging a particular email. Now, on the iOS 8 features list, there were certain iOS 8 features or gestures which were introduced only for the iPad. Just a moment. Yeah. So when you were composing your email, you want to, you know, do copy paste or select, you could use the iOS 8 gestures to be able to do so. Um, the, the swipe on the compose window would give you quick access to the various uh, inbox items, and from there you could choose what you want to do. In Safari, there are a bunch of gestures which would enable you to move from one tab to the other tab. So iOS introduced a lot of, or Apple introduced a lot of gestures for Safari in iOS 8. Now, you could hide or unhide the quick type feature on your, you know, on your phone by just swiping up or down, depending on what you want to be doing. iOS 8 also introduced certain accessibility features, which also gave the speak screen where it would read out certain messages for you, and this could be enabled from the accessibility control center, which was a part of the settings panel, which was introduced in iOS 8. A really intelligent feature, keeping in mind the various accessibility needs and regulations that are there currently. Now, iOS 9 introduced certain features. Some of them were universal, which was across devices. Now, for example, to go back to the albums, collectors, or moments in the Photos app, all you need to do was to swipe down on it, and that is how you go back. Similarly, if you swipe down on a particular image, then it goes back to the conversation on that screen. And you can drag your finger over multiple photos in the Photos app to select all of them at once. Now, earlier you had to do it one by one. Now you could select multiple at a time. Specifically for iPad, the slide over multitasking feature was enabled, where you could do multiple tasks. Like for example, here you can see the Periscope app and the Twitter app together. So you could that was introduced in iOS 9 for iPad. Again, the split view was introduced in iOS 9. And then iOS 9 also introduced something called as 3D touch. Now, this 3D touch is, in essence, an extension of the haptic feedback feature, which is available on almost all phones. If you have an Android phone, then you would see that long press would, on a particular screen, would open up the clipboard options. Now, this long press, the way your phone interacts based on this long press is that, when you press your on the touch screen for a certain duration or with a certain amount of pressure, the phone generates a feedback to this pressure to your touch, and based on that the clipboard menu gets activated, so you have the copy paste option coming up in case you want to do the copy paste. Now, what iPhone in case of iPhone, what happened in iOS 9 was they took it a step further. They started measuring the intensity of the pressure that you apply and the duration for which you are actually doing, so that they could open up more menus, just rather than just the clipboard menu, which was available on certain apps such as email. Now, here a particular example has been given in the screenshot. If you have the Shazam app, now if you would know, then that is an app which shows you the entire, history of that song, and it tells you in detail about that particular song. So here, if you use the 3D touch, then it allows you to search, it allows you to enable visual Shazam, auto Shazam. That is, for every song it will give you the information. So this is one quick actions that 3D touch does. The next one is peek and pop. That is, you could look at the preview of certain text or certain application without actually getting into that particular application. And then, if you based on the pressure that you have applied, now certain apps which gives you the thickness of a brush that is required for painting. So if you are trying to draw something, then it gives you various options depending on the pressure that you applied. So these are some of the aspects of the 3D touch that has been introduced. I think it's a brilliant feature, and it obviously does produce a few challenges in terms of being able to test it, especially when automation is applied. However, this is an important thing which you would not want to miss, because most of the applications on the iPhone 6s are now introducing the 3D touch feature, and it is very important. So the next few series of iPhones that are going to come out are going to see more and more variations of this particular 3D touch. Now, moving over to the Android gestures, the Android gestures, common gestures are, of course, the touch, which we are all familiar with. Then, of course, the long press, which I just mentioned a while ago, which is more of the haptic feedback which is generated, and then the action happens on the screen. Then you have the swipe and drag gesture. Then you have the long press and then drag. Then you have the double touch or the double touch drag, the pinch open, which is for zooming out, the pinch close, which is for zooming in, and then you have these other gestures, which is one finger, two fingers, three fingers, four fingers, or even five fingers gestures. So there are a lot of these applications, and there are a lot of the phone manufacturers themselves. They build in these features where you are able to use the gestures using your fingers to either unlock the phone or access a particular application or go to the control center, and so on and so forth. So it entirely depends on what the phone intends to do or the application intends to do, and then you act on it. So when you are trying to test a particular app, then you would want to make sure that you have a clear idea about all the gestures that are going to work on that particular app, and you're going to take your action accordingly. Now, some things to remember are that apart from OS level gestures, there are gestures which are specific to the apps, customized to suit the custom OS or the ROM that is installed. Now, before I explain what this is, let me talk to you about what these custom OSs or custom ROMs are. Now, the if you have a Samsung phone, for example, the Samsung phone does not use Google's native you know stock Android in itself, and then make sure that all the apps and the features are integrated and dish it out to its customers. Samsung has got something called as a TouchWiz UI. So for operating the UI of that phone, Samsung makes certain variations to the Android, the stock Android that is available, and then make sure that those variations are unique and are only available on Samsung phones. And then it gives out to you so that it becomes easy for the users of the Samsung phones to be able to use it. Similarly, if you look at, say, for example, the OnePlus series of phones, the OnePlus 1, the OnePlus 2, OnePlus 3, or OnePlus X. Now, initially, OnePlus came out with Cyanogen Mod, which was a variation of Android, which was not the stock Android, but certain features were different. And it was again a custom OS that was built onto that phone. The next generation of phones started having OnePlus's own operating system, which is the Oxygen OS. And this OS again was a layer of UI on top of the Android UI, specific to this particular phone. Similarly, phones have custom ROMs installed which allow you to change the operating system from time to time. Now, in the Android world, just a moment. In the Android world, most phone manufacturers give a custom UI, a custom ROM to its users to create the variation, and that is why you are seeing a huge amount of fragmentation in case of the Android phones, because Android is customizable, so that is why so much customization is happening. All apps have their own gesture set defined. So before you start testing a particular app, you make sure that you have a thorough knowledge on the gesture set that the app provides or the app supports. And then once you have the list of gestures, you need to make sure that you test it on devices or platforms which support those gestures. There is no point in testing them on devices or platforms which do not support those particular gestures. Your application is going to fail in that situation. Now, a lot of gestures such as the heartbeat monitor are dependent on sensors. So a lot of times the wearables, for example, the smartwatch that Samsung has, is compatible with the Samsung smartphones. So you could actually record the data on your wearable device and then pass it on to the phone, or the other way around. I mean, but then in each event, it is the sensor which is the main source of information. So you would want to make sure that when you are testing, you keep the sensor in mind. Well, that brings us to the end of today's webinar. I will now look at some of your questions and try and respond to those. Okay.
Hi, Brijesh.
Hello.
Hi, this is Surbhi here.
Yes, Surbi.
Brijesh, I have questions. I
Mm-hmm.
mean, through this webinar, we came to know the sensors, and we should test the sensors.
Mm-hmm.
But I'm looking for is how do we test it, and how do we get the list of the gestures to test it? I mean, normally when we get the app, the client does not know what gestures and all, and we build the app, be
Right.
it a hybrid or any.
Right.
So I mean, we don't have any kind of list, or we don't get anything in the practical scenario. So what is I mean, how should we go about that?
Okay. That's a very interesting, and that's a very basic question that almost each of us should have as to how do we go about testing these. Now, this at the start itself, I mentioned that this is more of a strategy that you are forming as to how or what all is going to be your coverage. So the focus here was essentially on what items you're going to cover, what are the various kind of gestures that you're going to cover. So, like for example, so most importantly, in the last slide, just before this, I put a case where there was a point that was mentioned that you need to know the gesture set of your particular application. So if you are building that application yourself, then you should be knowing what are the gestures that are going to be supported in that particular app. Now those gestures should be in accordance to the intent of your particular application. Say for example, the most common application that uses orientation as a feature is your YouTube app. Now, the YouTube app, you could see it in the portrait mode, or if you want to see it full screen, then you rotate it, you get the full screen on the landscape mode. So you would know that the gestures would be to actually shake and turn around your phone between various orientations. So you would know that your acceleration sensor would come into play in that case. So that is why it is important that I have listed out a few of these sensors in the slide. I would want you to go ahead and explore your phones, your devices, and try and understand what these sensors are. So in order to be able to do that, if you want to find out what sensors are there on your phone and which ones are active, which ones are inactive, then I would suggest an app called CPU Z or CPU Z as it is called. It's CPU, C for cat, P for parrot, U for umbrella, and then Z. Okay, so that is the app CPU Z. If you uh, download and install that, that shows you the various features of your phone. It tells you about the operating system of your phone. It tells you about the temperature on your phone. It tells you about the battery status on your phone. It also tells you about the various sensors. That is a very good starting point. This app will give you an idea of the various sensors that are, first of all, there on your phone, and the ones that are active. Okay, so if you, that will be a starting point for you. So you will have an idea of, okay, these are the sensors which are there on my phone. So if I have to test my app, which are the ones that are going to be used based on the gestures that I'm going to be using. Now, another example that I would want to give you is the autofocus on your smartphone, or the camera on your phone. You know, there was for particular phone that came up which said, okay, it detects smiles and only then it does the autofocus. So that was, I think, Sony brought out that feature which would detect a smile. So that would be a gesture which would be captured by your camera, and then the phone would actually evaluate, okay, if it's a smile, then the autofocus would adjust itself accordingly. So this was the intelligence that was built into the app, and the sensor for that was the camera itself.
Okay.
I
Thank you, Pritesh.
Yeah, I hope I've answered your question.
Yes, to some extent, yes. Rest, I think we are supposed to figure it out.
Yeah, you need to take certain steps. In case you have any further questions or queries, you obviously can reach out to me on this email address or on these Twitter handles. Please make a note of these. Uh, then I'll be able to answer your questions in detail. And okay,
Yeah.
some of the other questions that have come, I will try to look at some of these questions. Uh, okay, a lot of these questions are a lot of these questions are on automation. Okay, so there are commercial and there are free automation tools that are available in the market. Okay, my recommendation would be to, you know, try automation tools such as APM, which are which is a very handy tool to be able to automate your mobile tests, and this works very well with Selenium, and the integration would help you generate a lot of tests and a lot of results faster. So that is one suggestion that I have for you. Then there's another question which talks about the difference between native web and hybrid apps with examples and the frequent misinterpretation. Okay, so the most important point to note here is that these three categories of apps are again with categorized based on what they are and on what platform they work and on what platforms would they want to interact with each other. So, for example, native apps are apps which are built in a particular native environment of that device. Say, for example, there are apps which are native to iOS and there are apps which are native to Android. So you cannot have the same app operating across these two platforms. Just to give you an example, the Twitter app for Android is significantly different from the Twitter app for iPhone. So both of them are in fact native apps. However, If you compare the YouTube app is more of a hybrid app, which is same across iOS and same for Android. Now, the interesting thing is that, of course, iOS lets you install your applications through their market, and Android through their market. So obviously, they are structured differently and they are built differently. Okay, their extensions are different, so that they are installed differently on your phones. However, they the basic point is that when the app does not change itself and is interoperable between platforms, that is the basic disambiguation between native and hybrid apps. The other category of apps is are the web apps. Web apps are the ones which lead you to open a browser to complete a particular action. And the best example for that app is an app called Local Circles. Local Circles is a community app which helps you build community around a particular theme. So, for example, just to give you an example, when the Swachh Bharat campaign was launched a couple of years back, there were a lot of people who tried to use this app and tried to create a lot of communities for Swachh Bharat around their locality. So the local circles app was used. So what it would do is once you get into the app, you would want to register for that local circle. It will take you to the browser of your phone and then have the next steps followed from there. So that was a perfect example of how a web app was. Um, Okay, there's another interesting question. The question is, how do we automate sensors? You cannot technically automate sensors, but you can try and automate the gestures s- which those sensors support. Hmm, okay, I think I've answered all questions. Do you have any other questions?
Yes, I have.
Yeah, please go ahead.
Uh, now, suppose I mean, you showed us a slide for a mobile strategy.
Mm-hmm,
So, which is again, in normal terms, we know that we should test the feature which are impacting business more and all.
mm-hmm,
But actually, in practical situation, when we are supposed to test a mobile for 2 hours, for example,
mm-hmm.
what should be the ideal strategy we should follow?
Guidable inclusions. Okay, the reason why I say, I mean, jokes apart, the reason why I said this is because, you know, this gives you 18 top parameters, these 18 top parameters are nothing but their coverage areas. So for a particular mobile app, you would want to cover certain areas uh, for sure, and these 18, if you cover, you are sure that you've covered almost 100% of it. Along with it,
Okay.
along with guidable inclusions, if you can do, if your time permits, if you want to do performance, nothing like it. So just to give you an
Okay.
example, there was a competition in which this guidable inclusions was used. Uh, an app, one of the most famous chatting apps, which was built in India, was put to a crowd testing event, and the challenge was to test the app in 2 hours and give as many defects as possible. So once this strategy was applied, that you test some of the gestures, test the interfaces, you test interrupts, you test security features. So when every parameter was there, there were in 2 hours we were able to give almost around 40-45 bugs which were unique. So
Okay.
that is how you can use it. So there are multiple of these mnemonics available. The most common one is of course long fun cup, which we discussed. Okay, but guidable inclusions is something that is recommended because it is a little more than long fin cup covers. Any other questions?
Okay. Yeah, one more question.
Hmm.
I might sound little silly, but like suppose we know that all the app consumes battery or
Right.
memory, RAM,
Hmm.
and all, right,
Hmm.
and we can see also when we test. Okay,
Hmm.
but we don't know actually what should be the standard. I mean, how much battery an app should consume. I mean, then it is always expected versus actual. So it's like we don't know the expected. For
Okay.
example, any one app, like any gaming app, okay, it might consume more battery. Okay, now more battery could be 70%. Now we, normally we don't know what should be the ideal. Should it be 30%? Should it be 10%? You got my question?
Okay. Now this battery usage and memory usage and all these are, of course, a part of performance testing of your particular device, of your particular app. Now, before I answer your question, let me just disambiguate mobile testing for you a little more. So, mobile testing is divided into three basic categories. One is mobile device testing. The second one is mobile networks testing, and the third one is mobile apps testing. Okay. So when you talk about mobile device testing, you test the hardware of the device, and you test what kind of software does it support. When you talk about mobile networks testing, then you test the various networks that are available. So if today Reliance comes and says that, okay, we have 4G which is faster than Airtel's 4G, so you would want to test their 4G and establish that whatever they are saying is correct. So for that, you would need 4G enabled phones to be able to do that. And then the third category is mobile apps testing, which we are talking about. Okay. In this, it is very important for us to know that the non-functional testing plays a very important part. And in the non-functional testing, when you are talking about performance parameters, battery and memory and CPU and other stuff comes very handy. Your question, you would need to do a benchmarking just as you normally do in case of performance testing. You would need to create a benchmark as to what is the maximum allowable battery usage that this app should have. It cannot be that uh, you know you have an app which drains almost 60 to 80% of your battery. Just to give you an example,
Yeah.
the
Okay.
face just to give you an example, the Facebook app, if you have it on your phones, most of us do have that on our phones. We do not realize that it consumes the maximum amount of battery amongst all the apps
Yes.
that are available. Okay, and the way to find out is you uninstall that. So the big question that comes out is, how do I access Facebook? Well, open it on the browser.
Okay.
Okay, so if you open Facebook on your browser, the battery consumption will depend on the battery consumption of your browser and not on the app. Whereas if you have the app, then what the app does is it tries to connect to your network constantly, and it tries to fetch data for you, because it doesn't know as to what point of time in the day you are going to be accessing that app,
Yeah.
right? So you need to create a benchmark first, that okay, you know what, if the app is currently consuming 70% of battery, what are the parameters in the app that I should cut down, so that the battery usage is reduced.
Okay. Got it.
Got it? Now, say for
Yes.
example, just giving you the example of the Facebook app. Okay, the Facebook app, if you cut down the the access to the network, that is, if you make it periodic, that is, instead of doing it every minute, if it tries to access, Okay, so what I was saying is, if you try to say that the Facebook app connects to the internet for data every 15 minutes instead of every minute, then you will see that for those 15 minutes you are saving certain amount of battery,
Okay. Yeah, got it.
right?
Yeah, thank you.
Yeah. So in the chat window, I think Ramesh and Abhinaya have made some very good points. So yeah, Ramesh does talk about profiling. He's also mentioned about there are apps which are location embedded and that would take more CPU. Yes, of course. Uh, then there are comparable apps. You cannot, Abhinay says that you cannot compare battery usage of a map app with the app that enhances your photos. Absolutely. Yes. So you would want to compare apps of similar kind and not two different kinds. Now, another heavy battery consuming app that was obviously there was Candy Crush, which was a real battery drainer. And of course, of late, Pokemon Go is a masterpiece in that, in terms of battery consumption. It drains your battery really fast. So if you are a Pokemon Go freak, then you would want to have a power bank ready with you all the time. Ola, yes, of course, is another one of them. Well, we will talk about battery consumption and other some of these parameters in the other parts of the webinar series. So thank you so much for joining in today, and we look forward to seeing you in the upcoming parts of this webinar series. Thank you, everybody.